Particle-wave duality is one of the most striking findings of quantum physics. Simply put, quantum particles are not just particles, they are also waves, even though that seems a logical impossibility. And they are both of these things at once, yet also something more. This sounds paradoxical, and it is a paradox from a classical or materialist point of view, but recall that according to the Standard Model, particles aren't really solid little balls of matter, but processes that have relationships and interactions with other processes. Sometimes the kind of relationship they have with other processes will make them seem as if they were classical particles, sometimes as if they were waves. This was an entirely new kind of phenomenon for physicists and required of them a whole new set of concepts. Previously, all electromagnetic radiation of any kind, such as visible light, X-rays, radio waves, and so forth, was thought to exist only in wave form, never in particle form. It was not until the opening decades of the 20th century that physicists discovered that electromagnetic radiation could exist in both particle and wave states. Shortly after this, it was discovered that the two states were mutually exclusive, which is to say that light could be observed in one state or the other, but never in both states at once. We see light as either a particle or wave, depending on how we look at it, on what kind of relationship we have with it, and how we interact with it. Again, quantum particles like photons are processes that have relationships and interactions with other processes. And when a scientist observes a quantum particle, they themselves become the other process that the particle comes into relationship with and interacts with. This is so because in quantum mechanical terms, we too are processes since our bodies are composed entirely of quantum particles. If the equipment we are using is designed to look at particles, we will enter into that kind of relationship with the particle-wave duality that we call light, and it will appear to us as, and actually be, physically, a particle. But if the equipment is designed to look at waves, we will enter into another kind of relationship with light, and it will be spread out in space and appear to us as, and actually be, physically, a wave. There will be no particle in that case. Consciousness is needed to collapse the wave function, but we can also use our consciousness to determine how the wave function collapses, just by altering the experimental setup. Quantum physicists were beginning to peel back the surface layer of physical reality, and some strange fish were swimming there. They were beginning to glimpse the inner workings behind the actual construction of physical reality, and it was becoming apparent that consciousness played a role, and a central one at that, in the creation of reality. Needless to say, these discoveries were unsettling to physicists who felt committed to a mechanical model of reality. The idea that light could have both wave and particle characteristics was bad enough, but the realization that consciousness had a role to play in the actual construction of physical reality was much worse. It did not fit into the materialistic billiard ball picture of reality at all, but the experimental evidence bore out the concept. The complementarity. Light exists then as both a wave and a particle, but can only show one of its faces at any given time in physical reality. It is physically impossible for light to exist as both a wave and a particle at the same time. Physical reality imposes a limitation on light. It forces a choice, demanding that light be one thing or another. But what then is light like when it is not physical? What is this thing called light that can exist physically in one of two possible states, but exists prior to that, in the state of potentia, in some third state? Physicists cannot say what light is truly like. They only know that its definition must include the ability to exist physically as either a particle or a wave. In scientific terms, a thing like this, composed of contradictory or incompatible aspects, is called a complementarity. It is not simply that light is either a wave or a particle at different times. Something more mysterious than that is going on, for light is some third thing, the complementarity itself, that is neither particle nor wave, nor simply both combined. It is something more than that, something which cannot be expressed in physical reality. Light is something that can never be fully materialized as itself within our physical universe, but only in a limited form, or, as Seth puts it, in camouflage form, as either a particle or a wave. Light, like all complementarities, is always more than the sum of its parts. Shortly after the discovery of the particle-wave duality of light, and causing even more distress among scientific materialists, Louis de Broglie discovered that particle-wave duality applies also to matter. This meant that matter too was a complementarity composed of a wave aspect and a particle aspect, and that the old concept of matter as hard, irreducible little billiard balls was definitely wrong. The wave aspect of matter is a little different from that of light. Light is not matter. It is electromagnetic radiation and has no mass. Only matter has mass. Light can exist physically in its wave state because the wave is energy with no mass, and this energy can be measured using instruments. But the wave aspect of matter is different. It does not contain energy and so cannot be measured directly with any physical instrument. Its existence can only be measured indirectly, inferred by its effects. Instead of energy, the wave aspect of matter, such as electrons or protons, contains probabilities. Matter has a probability wave, which contains all the different possible versions of a given particle. Norman Friedman describes the situation this way. In the Copenhagen view, the quantum field specifies the probability of finding a particle at a given position in space if one happens to be looking. The particle is a manifestation of the field when observed. When we look at it, it is a particle. When we are not looking, it is a wave, but a wave that is not real. This effect of looking and not looking makes observation a key concept in modern physics. The entire wave appears to collapse down to a particle instantaneously upon being observed. The wave function, Friedman continues, describes conditions before matter makes its appearance. We never see the wave until it collapses into matter. In essence, for every formation of matter, there is a corresponding wave function, which contains all its probabilities of activity. But the wave function is essentially passive. It cannot stimulate action from within itself. It requires an agent to make a choice among its probabilities for the three-dimensional world to be formed. In other words, concludes Friedman, human consciousness is what stimulates action in the otherwise passive wave function. The important point here is that consciousness is the agent that initiates the transformation of a non-physical probability wave into a physical particle. Compare this with Seth's remarks on the role that consciousness plays in the formation of matter. In terms of your equations, Seth said, energy and consciousness and matter are one. And in those terms, consciousness is the agent that directs the transformation of energy into form. Consciousness and matter and energy are one, but consciousness initiates the transformation of energy into matter. Max Planck expressed almost exactly the same idea when he said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." In quantum theory, the term particle is something of a misnomer because it does not denote a solid, physical object in the terms usually meant. Even when an electron is behaving as a particle, it isn't actually a particle. It is still a set of relationships, and as such, quantum particles like electrons and photons don't take up any space. Physicists call them point particles because they have no extension in any of the three spatial dimensions. Quantum particles have no width or height or length, none at all. They are dimensionless. At the subatomic level, the solid, massy objects of classical physics melt away into dimensionless sets of relationships. Furthermore, subatomic particles cannot even be said to have any meaning when considered on their own. They are more like flowing webs of interconnections with other things than like little balls of matter. The meaning of a subatomic particle resides in its correlations with other processes, not in itself, in somewhat the same way that a chess piece derives its meaning from the web of relationships it has with the other pieces on the chessboard at any given time. And if one piece moves, the relationships of all the pieces change. A chess piece in isolation, considered simply as itself and removed from the context of the game, is void of meaning. In the same way, quantum particles derive their meaning from the set of relationships they have with every other quantum particle. The universe is like one big, ever-changing game of chess. In other words, explains physicist Fritjof Capra, subatomic particles are not things, but interconnections among things, and these in turn are interconnections among other things, and so on. In quantum theory, we never end up with any things, we always deal with interconnections. Quantum physics has shown that the physical universe cannot be broken down into irreducibly small elemental units that exist on their own as independent entities floating around out there somewhere in space. The quantum particles which compose all matter are patterns of relationships, and there is no lowest level to which everything can be reduced. In the words of physicist Henry Stapp, an elementary particle is not an independently existing irreducible entity. It is, in essence, a set of relationships that reach outward to other things. The 5 axioms of materialism have all broken down by this point because they are based on something that does not exist, irreducible material particles that behave in a deterministic fashion. That something does exist is undeniable, but it is not based on the classical concept of matter. The interconnections and relationships that exist between subatomic particles are not physical in nature. They are not material bonds that can be pointed to physically. They are more like mental or psychological patterns, which is why physicist James Jeans could say that the universe begins to look more like a great thought than a great machine. At root, the universe is mental in nature, not physical, and it is more appropriate to frame a discussion of it in terms of consciousness rather than matter. If we are to have any hope of understanding reality or ourselves, we should turn our attention to the study of consciousness instead of matter. But before we do that, there are 2 important quantum experiments to look at. They illustrate what has been said so far and provide real-world examples of the role consciousness plays in the construction of physical reality. The results of both experiments would be absolutely impossible under materialism, but are fully compatible with Seth's consciousness-based paradigm. The first involves a famous experiment known as the double-slit experiment, which proves conclusively that consciousness is crucial in determining whether a quantum system, like an electron, will behave as a wave or a particle. The second involves so-called entangled particles and action at a distance, and was carried out in response to a criticism of quantum theory made by Einstein. The double-slit experiment. This is probably the most famous experiment in the history of quantum physics. Physicist Richard Feynman writes that it involves a phenomenon which is impossible, absolutely impossible, to explain in any classical way, and which has in it the heart of quantum mechanics. The double-slit experiment proves that quantum particles can behave as either waves or particles, and shows that the manner in which they are observed determines which of these behaviors they will exhibit physically. In other words, our conscious choices, about measurements in this case, determine the kind of physical reality that a particle will actually have, and it is not the case that particles exist as independent, objective lumps of matter, moving about out there in space and time. Consciousness affects matter in a fundamental way. In classical physics, a system of interacting particles is expected to function like clockwork, predictably and deterministically, regardless of whether or not they are observed, but in quantum physics, the observer interacts with the system to such a degree that the system cannot be thought of as having its own independent existence.